Everybody's muted, which is good, so we don't.
Hello,
Hey,
this is Abby.
hey, Abby. So hopefully everyone's doing good, and everyone's staying healthy and safe and practicing social distancing and everything. Um, so here we are again. We're gonna be doing this every week, and we have almost everybody, but I'm going to be recording this to post it to anybody who wants to review anything we go over, or for anybody who wasn't able to make it today. So, what I was thinking we would do today is first, I really want to open the floor up for any questions you guys are having about the first statistical assignment. Um, that'll be like the first thing we do as a group. I'm going to go over a couple quick announcements. But then after that, I do want to go over the content that has been posted on crosstabs and correlations. Okay, I know that material won't be pertinent until the second statistical assignment is due. So I know you guys are still working on the first stat assignment, but just to keep the flow of class going, I am going to continue introducing content on inferential statistics. And with those, each week I'll have an opportunity to earn a bonus point. Okay. So, in terms of announcements, uh, hopefully you guys got an invite. What I'm also going to be doing is I know that not everybody feels super comfortable asking questions in front of all your peers when we meet up every Wednesday. So what I did was I created 2 hours of office hours, and those will be tomorrow and Friday morning. And let me bring this up really quick. Um, I believe they are, I'll tell you right now. Yes, they are from 10 to 11. So that's tomorrow, Thursday, and Friday from 10 to 11. I'm going to be hosting basically virtual office hours. So that's an opportunity for people to come to drop in. A number of students have emailed me asking to set up like individual times to meet. I am happy to do that, but what I would really like is for those of you who do have questions to pop in and either ask them here or to ask them during those office hours tomorrow and Friday. So those are some of the big announcements. The other things I wanted to bring up were that I am going to be going through the bonuses that you submitted and giving you feedback on those in the next couple days. So anything that might need to be corrected, you will have that before that first statistical analysis assignment is due. Above and beyond that, I definitely have been interacting with quite a number of you via email, especially as you come into challenges doing the first statistical assignment. Definitely happy to continue responding to those. What's really, really helpful is when you send me questions or different challenges you're experiencing, also send me your Excel spreadsheet and give me a bit of context of exactly what the issue is. So I can quickly review the spreadsheet and then give you some feedback. Okay, and above and beyond that, I did want to note, I kind of already mentioned this, I posted a couple videos, 2 videos, one on crosstabs and one on correlations. Now, I haven't created the bonus like assignment yet, but when I go over that content, after I open the floor up for questions, I will talk about what that bonus point for this week is going to look like. Okay, so Yeah, and then just to recap, everybody should have received your grades as well from the group evaluation plans. I thought you guys did an awesome job on those. I did provide some feedback, around how to make basically the evaluations better. But overall, I could tell that you guys put a lot of effort into those, and everybody basically took the comments I gave in the initial first paper that you used very seriously and incorporated that feedback into your assignments. So that was something that I really appreciated seeing. So definitely kudos on those assignments. You guys did a great job. And I believe at this point, what I'm going to do is really open the floor up for any questions you guys are experiencing, uh, particularly with the first statistical assignment that many of you have already started working on.
Hey, this is Abby again.
Hey, Abby.
Hey, I just had a quick question. I remember from our last meeting, you said something about gender for this assignment. You did eliminate that from this assignment, correct? Because it's not in the Excel spreadsheet.
That is correct. So if you look on the assignment description in Canvas,
Mm-hmm.
the frequency should now only list age and race, not gender. So
Okay.
yeah, I did update that on the assignment page in Canvas. So good question. So when you're going through and doing the first statistical assignment, you only want to report frequencies for both age and race.
Okay. Thank you.
Yeah, you're welcome.
This is Brianna Usry. I just had a question. Are we doing anything with the football category that's listed on there?
Not yet, not until we get to the T tests.
Okay, got it.
Good question.
And another question, I just want to make sure I understand. It says report the means, standard deviation, and range for the three subscales. And those three subscales that you want us to report that for are cynicism, professional efficacy, and exhaustion, correct?
Yes, that is correct. That is
Okay.
correct. And for those, you'd want to report the means, not the totals.
Okay.
Very good. Okay, so what other questions do people have? I know you have questions because I've been responding to quite a few emails. Don't be shy. It's okay to ask in this format.
For what Brianna was saying. Um, I use the data analysis to get like the range mean, like, so it has more than just those three, like the standard deviation, range, and mean. It has like all the other categories. And what I found was that my answers were, I guess they were accurate, but they're like 0.01 decimal off a little bit. So I don't really know what to do about that. I was going to email you about this today, but I figured I'd just ask you now.
Oh, yeah, yeah, very good. So when you say they're off, have you been comparing them to like other students in the class that are also doing this?
Yeah.
Yeah, so what could this is probably it could be one of two things. If it's like 1/100th off, then it could just be like a rounding error, either on your part or on the other students' parts. So if you're rounding, generally anything that's like 0.05 and higher, or 0.005 and higher, you want to round up to the next hundredth place. So it could be something to do with rounding. Because if there was a like a significant issue with what you were doing, it would be off by a lot more. So this
Okay.
might be a perfect instance where um, you know, it might be best to send me your data set, but I'm not exactly sure what I'm going to see because I'm not going to be able to compare it to other students you're comparing it to, but I can compare it to mine and just see if there is any issue. But being off by a hundredth, um, yeah, it's probably just something going on with rounding.
Okay. Thank you.
Yeah, you bet. Oh, one other thing about that. Something that you might want to double check is like the mean formula or mean computation that you're using for the subscales. You've probably already double checked that, but just to make sure that there isn't some error in the calculation. But again, if there was, it'd probably be off by more than just a hundredth place.
Okay, so should I just send you like my Excel sheet, or should I just wait till office hours tomorrow?
You can send me your Excel sheet.
Okay.
Yeah. Great. Okay. So, what other questions or comments do people have at this point?
This is Brianna again. I have another question where it says using the mean scores, compare them by age. What do you mean by that?
Yeah. So, basically, in the Excel spreadsheet, you have two different age categories. They're indicated by one and a two. And one refers, if you refer to the code book, is all persons between the ages of 21 and 25. And then the age that is marked by a two refers to all persons who are age 26 and older. So, what you want to do for that part of the assignment is take a look at the means for the three scales by those two different age groups. So, essentially, you're asking what are the mean exhaustion, cynicism, and professional efficacy scores for persons age 21 to 25? And then what are those mean scores for persons age 26 and over? And one way you can do this is by running descriptive analysis with only the persons, from the first age group highlighted, and then run the same descriptives for the persons of the next age group highlighted.
Okay. I'll probably need more clarification, but I'll use office hours for that question.
Okay.
This is John.
Hey, John.
Hey, I just had a question about the write-up portion
Mm-hmm.
and whether there's like a sample or anything that we can follow, or am I just sort of writing like you give a couple of like, for example, sentences in the assignment description? Am I just kind of replicating that for like your sentence about African American? Am I doing that for all the races or your exhaustion score? Am I just kind of copying those sample sentences and listing them on a document? Like you said, it doesn't need to be in paragraph. Should it be single space, double space? Like I'm just confused about that part.
Yeah, that's a great question. I definitely provided those with the idea in mind that you'd more than likely be pretty much replicating them, because that's generally how frequencies and descriptive statistics are reported in APA format. And in terms of what your assignment looks like, I don't think I put any specifications on whether it should be single or double spaced or have a title page or anything like that, because I'm really going to be grading you on the Excel spreadsheet, so looking to see if you were able to do the analyses correctly, and then looking at basically the write-ups. So I really don't have much of a preference for what the actual assignment looks like in terms of if you want to use single space or double space. A title page probably is going to be redundant because the entire write-up is going to be probably only a third of a page or less. So it'd be fine to just put your name at the top of a document and use single or double spaced, and really use those examples in the Canvas assignment page as a template basically for what your results should look like. Now, the only part where I'm really looking for conditional sentences that have to do more so with interpretation has to do with the descriptives, but specifically with age. And an interpretation can really be as straightforward as, persons in the age group 26 and older experienced higher scores of exhaustion than persons aged 21 to 25. You guys see my cat in the background? No? Okay. Does that help, John?
Yes, I was just gonna that I'm glad you got to the interpretation part. Is that just like you just said, a very objective reporting of comparison, or are you looking for like, do we have any hypothetical thoughts about those comparisons?
Yeah, I mean, if you do have some thoughts, definitely feel free to include those. If you do have some like hypotheticals, but that isn't really what I'm looking for. But inevitably, some people do put them, and they a lot of times are pretty interesting to read. Um, but in general, in terms of like interpretation for this, it's really that like raw objective interpretation of, are these scores higher and lower? Maybe a sense of as well like the magnitude of the difference. So what I mean by magnitude is if on the exhaustion scale there's like a point one difference, there really isn't a difference there. If there's a zero point 0.5 difference, then there's a slight difference. If there's like a 2.0 difference, that's fairly large. So magnitude in terms of that basically in the interpretation. Great question.
Thanks.
Yeah, and if you did want to couch a little interpretation in the descriptives of like the entire samples, exhaustion, cynicism, and professional efficacy, you could do that. And what you'd really be using is just the Likert scale. Similarly to how most of you wrote up your interpretation sections in your paper, where you basically said, if they scored like, a 2 out of 7 on burnout, that would mean that burnout was pretty low. Whereas if there was like a 5 out of 7 on burnout, then burnout would be pretty high. You can put, like the class or the sample experienced high levels of emotional exhaustion, that it was a 5.5 average out of a possible 7 or something like that. So you can add in like very minor interpretations to the frequency or to the descriptives. And probably you could do the same for frequencies, but they don't need additional sentences. You could just say like the majority of students in the class were Caucasian, and then in parentheses the count, the percentage, and then you could say like followed by African American, and then the other category. Does that help?
Yes, thank you.
Yep. Great. So, what other questions do you guys have about the first statistical assignment?
This statistical assignment, you have to have the analysis tool pack as well, correct?
Yes. Yes. I mean, you could do you could do the descriptives by hand. Let me reframe. You don't need it for this assignment. but it would make it a little bit easier. But even doing it by hand is fairly straightforward, because you can just do the equals average and then click and drag on the cells you want to compute an average for. But with the analysis tool pack, you could also go to like descriptives and then click and drag on the cells that you want to include. And then that would give you like everything at once. So it would give you pretty much like a long list of descriptive statistics, but it would include the mean, the standard deviation, and the range as well.
Okay, thank you.
Yep. Nate, stop. Stop. Get out. Okay. So how about we transition into the crosstabs and the correlation conversation? Have people had the opportunity to watch those videos yet? Nate, get out of there.
I have. This is Lacey. Yeah, I watched it a little bit before this, and they were really helpful. In addition to the Word document that accompanied it, like I would definitely recommend reading that through first, just so you have an idea of what is going on.
Great, great, Lacey. Yeah, I definitely would encourage that too. So we transition more to pretty much like Word documents and videos at this point, as opposed to PowerPoint presentations. So I try to be as like explicit as possible in the Word docs that basically just kind of go through step by step. Basically, how do you do this in Excel? And then in Canvas, on the actual Canvas page, that's filled with a little bit more content on like what is crosstab? When do you want to run a crosstab analysis? Like what is a correlation? When do you want to run a correlation? And then the doc and the videos really kind of go through how you do that in Excel. Okay, so they definitely, I definitely would discourage like even asking me or emailing me any questions until you go through those documents, because you know it is apparent when people haven't watched the videos when they're asking questions, because they are pretty explicit. But when you are trying to run the analyses based on what you found in the Word docs and the videos, and you're having errors or having difficulties running them, that's definitely when you want to reach out to me and I can assist you and help you out. But great feedback, Lacey. Thank you. Okay, so any other questions about crosstabs and correlations?
So this isn't really like about the topic exactly, but I guess what are you looking for in the bonus specifically?
Yes. So in the bonus this week, what I was thinking is that it'd be very similar to last week, where basically in this week's bonus, what you guys are going to do are going to replicate developing or doing a chi-square test in the crosstabs. So you'll create your table with the observed values and then the expected values, and then get that probability level. And then with the correlation, you would run the correlation. So just doing those two things would probably take folks about 5 to 10 minutes after watching the videos. That's going to basically earn you half of a bonus point. Now, in the Word doc, there's two sections that are in bold with exclamation points that put bonus. That basically is how you could earn an additional half of a bonus point. To where if you actually try to compute the chi-square test statistic in Excel and compute the Pearson correlation with the probability level with the correlation. So that basically is what the bonus is going to look like. And I know a couple people emailed me. Basically, I wanted to also announce to folks, I haven't done this in the announcements yet, but there aren't going to be any more quizzes for the semester. What there are going to be are these participation / bonus point opportunities where you don't get penalized for not doing them, but you can earn a bonus point for doing them. And then really the idea with these bonus point activities is to give you the hands-on experience working in Excel, sending me, your spreadsheets demonstrating that you've done these. And these are really going to assist you a lot in doing the statistical analysis assignments. Okay, so to those of you who completed the bonus point for last week that I'm reviewing now, you've probably already seen that it's given you exposure and experience with doing frequencies and descriptive statistics to where you're really just replicating those pretty much on your own for the assignment. Okay, but for this week's bonus, it's again going to be replicating the analyses I did in the video with the sample data set. That will give you half a bonus point. And to earn the other half, you have to actually compute the chi-square test statistic and then the Pearson correlation and probability value. And this is all outlined both in the Word doc and in the two videos, one on crosstabs and one on correlations.
I have a question.
Yes.
This is Hannah. I was just wondering, are the bonus points on our assignments or on the entire grade?
Well, your entire grade is out of 100 points. Right, so 1 point is 1 point. It's all on the same scale.
Oh, okay.
Mm-hmm. So if you did the first bonus point, and it's evident that you went through, and this really is about the bonus points are about trying. So, if you didn't do it right or something like that, you're not going to get like partial credit. But if you only did half of it, but didn't do the full, bonus assignment, then you would get partial credit for that. But for instance, if you did the bonus point last week, if you had 79 in the class, that bonus point would give you an 80. Okay, so all the points are out of 100. All the different assignments sum to 100.
Okay, got it. Thank you.
Yep. Okay, are there any other questions about crosstabs or correlations? I will. I will go over very briefly. These videos, they are an opportunity to answer questions. They are also a chance to briefly go over some of the content. I'm not going to go over them as much in depth as I do in the videos. I spent a decent amount of time making those videos and going over and whatnot and editing and stuff. But I do want to say to give a little bit of content on crosstabs and correlations and what they are, and I'll be doing that each week during these videos. So basically, a crosstab it's essentially a type of frequency. And when you want to run a crosstab is when you have two categorical variables and you want to look to see if there is a relationship between those categorical variables. Okay, and a lot of times these categorical variables are binary or dichotomous, which means they have two response categories. So in our example in the sample data set, I used smoking and heart disease as two binary variables to see if there was a relationship between the two of them. And they're both straightforward yes-no variables. Either you smoke or you don't, and either you have heart disease or you don't. The reality of those two could be more complex, but just for this sample or this example, they're just binary variables. So if we want to see if there is a relationship between those two variables, and because they're categorical, we would run a cross tabulation. And basically what a crosstab is essentially a frequency where you break down all of the different possible response categories into a frequency. So if you think about it, if people either smoke or they don't, and have heart disease or don't, and you took a sample of, let's say, 1,000 people, then you'd have four possible responses to those questions. You'd have people that both smoke and have heart disease, people that smoke and don't have heart disease, people that don't smoke and have heart disease, and people that don't smoke and don't have heart disease. And what the crosstab basically is a count of how many of those people fit into each one of those four categories. So in that way, the crosstab is really a frequency. It's a count of how many people indicated that they both smoked and had heart disease. How many people indicated that they smoke but don't have heart disease. Okay, and essentially you can create a statistical analysis of those counts to see if there is a relationship between the two variables. And how you do that is if we have four response categories, okay, and if we can hypothesize that there is absolutely no relationship between these two variables, then people should evenly fit into each one of those four categories. So for instance, 25% of the sample would indicate that they smoke and have heart disease, 25% would smoke and not have heart disease, and so on for the other two categories. Okay, so basically what we're doing is we're comparing those expected, which is that there's no relationship and that everyone's evenly distributed across those four different categories, with the actual counts that we have. And that is the chi-square test statistic, is it's looking at how many people actually belong in those categories versus how many we would expect if there was no relationship. And if there's a difference between those two, then we're going to get a significant probability or p-value. Okay, so based on research, I kind of inputted what I thought the relationship between those two variables were when I manufactured this data set. And not to give anything too startling away, but there is a relationship between smoking and heart disease. So you'll start to see it as you go through and watch a video and then go out and do this on your own, that the people who indicated that they smoke are more likely to indicate that they also have heart disease. And you'll see that by larger counts in that category relative to the people that smoke and don't have heart disease. And you'll also see this on the back end, that the majority of people who don't smoke don't have heart disease relative to the people who don't smoke and do have heart disease. So you can kind of start to see just when you do those counts if there's a relationship between these two variables. Okay, and the chi-square test that you'll run in Excel, that's essentially what that's doing under the hood. Now, when you take a look at the actual computation for the chi-square test, it's very, very, very complex and it's super long. And I think the important thing to know about that is basically what I just said. That even though it's complicated, and it's probably it would take an hour to break down and a couple days to really saturate about why this is the way it is, just know that what it's ultimately doing is looking to see if there is a relationship between these two binary variables. Okay, so that is a summary of what a crosstab is. The crosstab is just the frequencies, and then the statistical test, the inferential test, is that chi-square test statistic in the accompanying p-value. Now, why I include that chi-square test in the computation is because when you ask Excel to do a chi-square test, the only thing it gives you is the probability value. It doesn't give you the test statistic. Okay, so if we wanted to know what the test statistic was, maybe we wanted to include it in a report, then we would have to use the formula and basically enter it into Excel by hand to get that chi-square test statistic. Okay, so what Excel does give you is whether or not there is a relationship, because it will give you the probability value, but it doesn't give you the test statistic. Okay, I'll stop there for a second. I definitely anticipate there to be a fair amount of questions about that, but there might be more that we can talk about in office hours or via email after you go through and watch the videos and then work on the bonus assignment or the practice. But are there any questions about crosstabs?
So this is another question about the bonus points. So where do we submit those? Do we just email them to you or what?
Oh, well, for last week's, I did create an assignment called Bonus Point, and I am going to be doing that today for this coming week as well. So you can just submit that on Canvas, and what you want to do is submit the spreadsheet that you're working on. That's actually the only thing that you have to submit. So no write-ups or anything like that, just the spreadsheets where you're really going through and replicating what was done in the videos on your own, and then submitting those to me so I can take a look at what you did.
Perfect. Thank you.
Oh, you're welcome.
This is John.
Hey, John.
So can you try to say one more time, like I'm looking at the Word doc as you're talking, what Excel is giving me and what it won't give me? I kind of got lost in that because I'm staring at this formula that looks completely insane.
Yep.
For doing the chi test.
That is what I was referring to, yes.
So the Excel gives me a p-score.
Yeah, it gives you
But what is it not giving me?
Well, I'm sorry, I missed the last thing you said.
But what's it not giving me?
It's not giving you that formula. So that formula is going to give you the test statistic. What Excel does give you is the probability value based on. Okay, so basically, what Excel is doing is that it's running an analysis, but it's not giving you an output other than the probability value. Okay, so when you put in the chi-square test, you put in, what were your observed values, what were the expected values, and if you create that table that's referenced in the Word doc through an image and then the video, you can get the probability value for the relationship. So basically, Excel does compute the chi-square test statistic, and it does know the degrees of freedom and the total counts. And based on those three things, it will give you a probability value, but that's all it gives you. It doesn't give you the test statistic. It doesn't give you, the degrees of freedom and the total counts. It only gives you a probability value. So if you were to run this exact same analysis in SPSS, for instance, and you wanted to run a cross tabulation, and then in the output section, you indicated that you also wanted the chi-square test of significance to see if there's a relationship here, the SPSS output would give you the chi-square test statistic, it'd give you the degrees of freedom, and then it would give you the probability value. Excel only gives you the probability value. So it basically just tells you whether or not there is a relationship here based on its significance. But in order to actually get that test statistic, you have to do that very long, complex formula to produce that, because for whatever reason, Excel does not include that as an output. But it will run the test for you and give you the probability value. Hopefully that helps. So basically, like in all inferential statistics, there's really three important parts of any test that you run. There's the test statistic, which differs based on what type of test you're doing. And then there's the degrees of freedom and the probability value. Okay, and most of the time, what we're most interested in is that probability value, because that's where we get all the talk of significance. So if the probability is less than 0.05, it's significant. If it's less than 0.01, it's more significant, and so on. But a lot of times when you're writing reports, especially in APA format, generally what you're reporting is the test statistic, the degree of freedom, and then the probability value. Now, you don't have to worry about that for the first assignment because we're not doing any inferential statistics in that first assignment. We're only doing frequencies and descriptive statistics. But come time for the second assignment in this week's bonus point, we are getting a little bit more into the inferential side of statistics. Okay. But that might help a little bit. And depending on the test, like for t-tests, Excel does give you the test statistic, degree of freedom, and probability value. But for whatever reason, with crosstabs, chi-squares, and correlations, it doesn't give you the test statistic. It only gives you the probability values for the crosstabs, and then it only gives you the correlation for the correlation command.
Okay, so just one more question
Yep.
to follow up. So I know this is like super tedious, but like I just don't know. This whole language is foreign to me.
Yes.
So I'm just trying to help it make sense. So the thing that I got from what you just said was that the probability value is the p-value, and you talked about like less than 0.05 and less than 0.01. That's perfect. For test statistic or degrees of freedom, like what's the symbol for it? What's the numbers that matter? Like I just don't know what I'm even talking about.
Yeah, so the test statistic in inferential statistics, it's different for each type of analysis that you run. So the chi-square statistic is very different than the test statistic for like a t-test. And they all have their own computations and their own like interpretations. But the important thing, I would say probably more than anything else, is that probability value, because you might get a chi-square test statistic of 27. Well, what does that mean? It basically means that it's pretty big. There isn't like a set indicator of like, 25 to 30 means X and 30 to 35 means Y. And a lot of times we will base our interpretations of those test statistics on the probability value. So understanding the probability value is kind of your golden ticket to understanding all the different stuff related to inferential statistics. Okay, so the chi-square does tend to be quite large, but like the t statistic that's used a lot of times in regression, in correlations, in t-tests, it tends to be a little bit on the smaller range. And basically, what those are is that it's basically looking at like the mean of two different groups and then subtracting one from the other and getting a mean difference. and then dividing that mean difference by a standard error. And basically what a standard error is, one way to think about it is that it's a standard deviation of the entire sample. And that gives you a test statistic. And then with that test statistic, you look at the degrees of freedom. And essentially what the degree of freedom is it's an illustration of power, like statistical power. So power is an important concept in stats. We really won't get into it all that much in this class. But the way to think about power is that the more people you have in a data set, the more closely they might represent the actual population. Therefore, the more power you will actually have in detecting differences. Okay, so the difference between a group of 10 people has to be much larger to be significant than it would if there were 100 people in the sample. And in most cases, the degrees of freedom for t-tests are the total number of people in the sample minus 2, because you're making 2 comparisons and comparing the 2 means. Okay, so if there's 100 people in our sample and we're doing a t-test, then the degrees of freedom is going to be the total number, or uppercase n minus 2. So 100 minus 2, which is 98. So our degree of freedom would be 98. Our test statistic would be the 2 groups we're comparing, their means subtracted from one another, divided by the pooled standard deviation. So now that we have that test statistic and our degree of freedom, we can check to see what the probability is. Okay, I'm going to quickly go over correlations as well. And really the basic thing we need to know about correlations is that anytime you have 2 variables that are both numeric, then if you want to look at the relationship between them, you generally will run a correlation. And kind of the classic example of this is looking at the relationship between height and weight. Those are 2 clearly numeric indicators. And to test and see if there is a relationship between 2 numeric variables like height and weight, you would want to run a correlation. Okay, and correlations always range from -1 to +1. So a 1 would be a perfect positive relationship between 2 variables. So 1 would basically mean that the 2 variables are identical to one another. Okay, and a -1 would mean that there's a perfect negative relationship between 2 variables. And the way to think about positive and negative relationships in terms of correlations is that if it's positive, as one increases, the other increases. Okay, if it's a negative relationship, that basically means as one variable increases, the other variable decreases, so that there is a negative relationship between those 2 variables. Okay, so correlations are always going to range from -1 to +1. And in general, we think about correlations as a correlation that's either negative or positive 0.3 is considered to be kind of small to moderate. 0.5 and above is more in that moderate or medium-sized correlation range. And anything really above 0.7 is a very large correlation, so much so that there's almost redundancy in the 2 variables that we're looking at. And redundancy in the sense that they're very, very, very strongly correlated with one another. Okay, so what Excel will give you when you run a correlation test is the actual R value or correlation. So when you run in the analysis toolpack correlations, it will give you a correlation matrix. And what you'll want to look at is where height and weight intersect. And in the video, you see that in this example, it's a 0.82 correlation, positive correlation. So height and weight are very, very strongly correlated with one another in this sample. Now, unfortunately, what Excel does not give you is the test statistic and probability value for that correlation. So in the videos, I walk you through the steps and the Word doc in how you compute the test statistic for a correlation and get a probability value for it. The other important thing with correlations is that in the video I walk you through how to do a scatter plot of the two variables. And basically what that is it's a bunch of like little dots that indicate each person's responses to height and weight. And from there, it gives you like a visual representation of what the relationship between these two variables is. And you'll see pretty clearly that there is a positive relationship between the two variables based on that scatter plot. And then I also walk you through like how to add like a best fit line to that scatter plot, so you can actually see from like a single line perspective what that relationship looks like. So definitely be sure to watch the two videos on crosstabs correlations. And as Lacey suggested, it might be best to read the Word doc first, and that might provide some essential context to the videos. And the resources in Canvas are also pretty good in terms of like defining what a crosstab is, what a correlation is, when they're used and stuff. Okay, so any questions about correlations? Okay, well, I'm sure you're going to come across as you're going through the bonus activity for this week. But I do again want to remind people tomorrow, Thursday, Friday, I'm going to be having office hours from 10 to 11. So feel free to drop in with any questions. You can share your screen so I can see what you're doing with the analyses. It's going to be another WebEx. Hopefully everybody got the invite for those, but I believe I also posted the links of those in Canvas under the week 12 module section. So definitely feel free to stop in with any questions or comments you have. But if there is nothing else, then it's great to see everybody, and hope you guys are staying safe. And I look forward to, continuing to work on these statistical analysis assignments together.
Thank you.
Thank
So
you.
much. Appreciate you both.
Thank you.
Yeah.
All right, you bet. Take care, everybody.
I do have a quick question.
Yes.
So for the basically for the bonus point, we're just doing the first part of the assignment.
Say that one more time. Sorry.
Basically, the bonus point is the first part of the assignment.
Of the assignment?
Yeah.
No. It's well. You're going to like the bonus points. You're going to be doing the same like statistical tests that you'll have to do for the assignment, but you're using sample data instead of the data sheet from the burnout inventory that you'll be using for the actual assignments.
Okay, so we're not using the smoking thing that you used in the video.
You're not using what?
The smoking heart disease example you used in the video, we're not using that for the assignment.
Not for the assignment, no. For the assignment, you're using the Maslach burnout.
The same. Okay.
Yeah. We're going to use that same document for the second statistical assignment as well.
Okay, thank you.
Yeah, you bet. It's a good question. Well, all right. Take care, everybody. I will see you next week.
Later.
Bye.